Now we're going to be looking at factors and multiples. Children should also be able to tell you what that is. If we go back to factors, factors are numbers that can divide into another number without a remainder. So you will work with whole numbers here. Okay, so there's our definition so that they can understand it better. A factor is a number, or a number is a factor of another number when it can divide into that number without a remainder. Okay, so let's look at examples. Factors of 15. So if you think of numbers that can divide into 15 without a remainder, two of them will be 3 and 5. There are more factors of 15, but we're just looking at these two as an example. Now, if you test it, okay, so 3 times 5 equals 15. So that's why we say these two are factors of 15. So I'm going to identify factors of two examples. So let's find the factors of 24. Now normally I will write F for factors and then I will say 24. That means I'm going to find the factors of 24. Now 1 is a number that can go into any number, divide into any number. So that is our first factor. Okay, so normally I tell the children I want them to think of what number multiplies with this equals this number that we are looking at here, the 24. So what times 1 equals 24? And that will be 24 itself. Okay, now we need to find the next factor. Now remember 24 is an even number, which means it can divide by 2. So 2 will be your next factor. What times 2 equals 24? And that is 12. Okay, you will see I'm writing it like this. It's like eating at a fancy restaurant. You eat from the outside inwards. Okay, so we start with the 2 on the outside and then we work towards the center. Right, so now we're going to think of, okay, so we started with 1 and now we're going on to 2, and now think of a next number after 2. 3. Can 3 divide into 24? Yes, it can. Right, so we write 3. And what times 3 equals 24? And that is 8. Okay, 3 times 8 is 24. Right, so then we move on. What number comes after 3? That will be 4. Can 4 divide into 24? Yes. So 4 times what is 24? 4 times 6. Right, so then I want you to look at these two now, 4 and 6. Any numbers in between, like 5? Can 5 divide into 24? We know it cannot, because the number needs to end on a 0 or a 5 for 5 to divide in it. So all these numbers that we have here, that's listed here, are factors of 24 because all of them can divide into 24 without a remainder. Right, now let's look at a bigger number, the factors of 72. I want to mention something here. When it comes to identifying factors, the times tables are crucial. If they don't know it, they will not be able to list the factors of numbers. Right, so now let's look at what do we start with here when we identified the factors of 24. We started with 1. Okay, so 1 times what is 72? And I'm just writing it on this side because the biggest value I write on that side, the far side. And that is 72 itself. The number multiplies with 1 will be the number itself again. Right, so now we look at 72. We see, now think of the number after 1, which is 2. Can 2 divide into 72? Yes, because this is an even number. So we will say, okay, 2 times. Right, now you need to think, what will multiply with 2 that equals 72? What you can do is you can half 70, then you will get 35, and half of 2 is 1, so 1 plus 35 is 36. So 36 times 2 is 72. Right, now you need to know what number after 2 can divide into 72, and that will be 3. How do I know that? I know that 3 can divide into a number when I add the 2 digits. 2 plus 7 equals 9. So I can write it here. 2 plus 7 equals 9, and 9 can divide by 3. That is just a test to know if a number can divide by 3. You add the 2 digits and then the answer you divide by 3. And if you get an answer without a remainder, you know that it can divide by 3. Right, so now you need to know, go ask yourself what number multiplies with 3 that gives you 72. Okay, so I want you to think a little bit what that will be. Do you find the answer? The answer is 24. 24 times 3 equals 72. So your next number will be 24. Okay, now you move on to ask yourself whether 72, what's the next number after 3? That is 4. Can 72 divide by 4? Yes, it can, right? So we will say 4, and what times 4 equals 72? That is 18. Right, now go on to the next one. 70 after 4 will be 5. Can 5 divide into this? No, because it doesn't end on a 0 or a 5. So after 5 is 6. Can 6 divide into this? Yes, it can. Okay. So now you ask yourself, okay, what times 6 equals 72? That will be 12. Because 2 times 6 is 12. And 10 times 6 is 70, and 10 times 6 is 60, and 60 plus 12 is 72. Right, now we go on, and you ask yourself, okay, next number after 6 is 7. Can 7 divide into this? No. Next number after 7 is 8. Can 8 divide into this? Yes. 8 times 9. Right? And then there are no numbers left in between 8 and 9. So these are the factors of 72. Very important to know your tables. Right, now this is factors and how we identify them. And now we go to another word that's called multiples. Multiples of a number is, I always explain it to the children, it's like counting in that number. So if we have to explain it more mathematically, we will say the multiples of a number are all the numbers that are products of the number or any other integer. So that's a mouthful. So if I say, for example, the multiples of 5, that means that's all the numbers that 5 can divide into. Okay, so the first one will be 5, the second one will be 10, counting in 5s. 15, 20, 25, and it continues. This one is the first multiple of 5. That one is the second multiple of 5. This one is the third one. That one is the fourth one. If I would ask you, what is the sixth multiple of 5? Okay. Then you just tell yourself, okay, 6 times 5. What's that? That is 30. So 30 is the sixth multiple of 5. If I use the small examples, what's the third multiple of 5? That's 15 here. And you can test it. 3 times 5 is 15. Okay, so multiples meaning it's like counting in the number, or you can just say, for example, the first multiple will be take 1 and multiply it with 5. The third one will be take 3 and multiply it with 5. So the multiples of 2 are 2, 4, 6, 8, 10, 12, 14, 16, and so on. It's like counting in 2. So that's why I've written here, we count in that number. Okay, now we're going to identify multiples of 8. So you will see it's actually easier to find multiples than finding factors, because factors you need to really know your times tables very well. Don't leave out any numbers when you write your answer. Okay, so let's go back to multiples of 8. So if I have to find multiples of 8, so the first one will be 8 itself, because 8 can divide into itself. The second one will be 16, because the second one means 2 times 8 is 16. The third one will be 24. Next one will be 32, and you can go on. The next one will be 40, and it continues. So it's like counting in the number itself. Let's find the multiples of 15. So the first one is the number itself. 15 then it is 30, then it is 45, then it is 60, and you go on counting in 15. Right, so say for instance, I want you to tell me what is the 100th multiple of 15. Then you will say, okay, 100 times 15, and that will be 1,500. Right, now we're just going to add on to the factors and multiples. The children can get a question like this. They need to identify the factor pairs. So I'm going to go back to my example of factors of 24. So let's just identify factors first before we see we identify the factor pairs. Okay, so we're going to say factors of 24, and again we're going to start with 1. 1 times 24. Then 2 times 12. 3 times 8, and 4 times 6. Now I've listed the factors of 24 again. And now I want to identify the factor pairs within this list. So that means two numbers, because pair refers to two. Two numbers multiplying with one another that equals 24. So 1 times 24 equals 24. 2 times 12, 3 times 8, and 4 times 6. So if I write the factor pairs, I will say 1 and 24 are factor pairs. 2 and 12 are factor pairs. 3 and 8 are factor pairs, and 4 and 6 are factor pairs. So written them like this: 1 times 24, 2 times 12, 3 times 8, and 4 times 6. So these are factor pairs. So now we go on to the last part. Multiplying whole numbers with multiples of 10. Very easy. I'll show you an example. 35 times 10. The answer is 350. But how do I know how to find the answer? Very, very easily. You can see within this number here, you have also a 3 and a 5. So there's the 3 and the 5 of 35. And then what happened is we added a 0 onto the end of the number. So you need to look at how many zeros you have in the 10. That will tell me how many zeros I will add on at the back of the number. So there's only one, so you will have 1 0 at the end of the number. So then you've got 350. Let's use another one, multiplying with 100. So let's use a big number, 23,493. Multiply with 100. Okay, how many zeros are there? There are 1, 2. So I need to add on 2 zeros at the end of this number. But now remember, big numbers are written in groups of 3 digits. So start with the 2 zeros at the back. And then you go on to what's the first digit from the right hand side. So that's 3. So now I have 3 digits already. So you need to leave a space. And then you write 9, 4, and the next 3 will be in the same group, and then the 2 on its own. So your answer will be 2,349,300. You multiply it with 100, so that means there will be 2 zeros at the end, because 100 contains 2 zeros. Right? Another one, multiplying with 1,000. Let's say 2,543 times 1,000. How many zeros are there in 1,000? There are 1, 2, 3. Okay, so then we will start with the 3 zeros that will be at the back of the number. Okay, and then my groups of 3 again. 3, 4, 5, 3, 4, 5, and then the 2 on its own. So your answer is 2,543,000. 543,000. Right, I hope you understand that, and then we will move on to our next lesson.